on a graph of the frequency in cycles per minute or half cycles per minute, and you would want to label that on your graph. If you have a 1 minute count, then we do a 1 minute count and we get the frequency either in half cycles or cycles per minute, versus length in centimeters, either F, S, D, or T. Let's say we just have 3 points. Okay, these 3 points on the graph can be pretty well approximated by a straight line. If I lowered that straight line a little bit, I'd do a little better job of minimizing the average distance between the points and the lines. Now, if we have a linear model, there's a problem, as we recognized in class. People pretty well picked up on it, that this point on the graph implies that there's some length at which your frequency is 0. Well, if the frequency is 0, well, that means you pull the pendulum back and you let go and it doesn't go anywhere. That isn't going to happen, at least not within reasonable lengths. You know, you can conjecture lengths that get far enough away from the center of the Earth that even gravity can change. But if the mass of the pendulum is close to the surface of the Earth and the supporting string doesn't have much mass compared to the mass of what's hanging from it, this isn't going to happen. Okay? So that makes no sense. You don't pull a pendulum back, release it, and it doesn't oscillate. It'll always oscillate. Now there's a question of whether we get an intercept here. It's very possible that as the length approaches 0, we have a point up here, a limiting point, where the straight line continues, so that the straight line approaches this limiting point so that the frequency or the count of the pendulum per minute doesn't exceed this value. That could well be the case. We can't make an infinitely short pendulum. There's a limit to how short we can make them and observe their frequencies. And, well, enough said about that. So we don't know. We don't know. Actually, we do know, but at this point of the course, we don't. Now, another possibility that fits this data, these 3 data points well, is this sort of a curve, which would be the sort of a curve you would expect if there's no limit to how long the pendulum can get. It's never going to reach 0 frequency, at least within the domain of possible lengths for our pendulums. And ideally, an ideal pendulum can get as long as you want, and ideally it does turn out that you just have an asymptote here. And that still leaves the question of whether this is a vertical asymptote or whether there's some point where this curve actually intersects the graph, some limit beyond which you are going to get a frequency. And actually there are quantum mechanical limits and so forth. But in the ideal model, it's going to turn out that this is an asymptote.